We will now discuss naming alkanes in more detail, because like we said before, you have to find the longest chain. That can be kind of tricky. For instance, when there's an isomer involved, an isomer is something that has the same molecular formula, in other words, the same number of carbons and the same number of hydrogens, but they're arranged differently. They're connected differently. For instance, if we take these two structures on the right, the black marbles are carbons. There's 4 carbons here. And there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 hydrogens. If you look on the bottom, 1, 2, 3, 4 carbons. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 hydrogens. They both have C4H10, but if we're starting to look for the longest chain, this one has 4 carbons connected, where this one has 3 and then coming up. So the longest chain on this one is 4, the longest chain on this one is 3. This is called a substituent. And that's what we're going to be focusing on with this section. Substituent is a group of atoms attached to the longest chain. So we have an alkyl group and we have a halo group. Remember, halogens are this row right here with fluorine, chlorine, bromine, and iodine. And when they're talking about the alkyl groups, that's from the previous section where meth was 1 carbon, eth was 2 carbons, prop was 3 carbons, and so on. Well, instead of having methane, ethane, propane, we're going to end in YL. So when it's coming off the longest chain, it's going to be methyl. And we're going to focus on how to name these in the next coming slides. See, 1 carbon is meth, 2 carbons once again is eth. So once you memorize those first 10, you're basically set. And then we have fluoro, chloro, bromo, and iodo. And we're going to talk about how to link these into the chemical name. Alright, first thing you're going to want to do is find the longest chain. So I picked this particular compound here because of the fact that there's several different ways you can name it. We have, if we look at this one, 1, 2, 3, 4, 5, 6, 7 carbons that way. 1, 2, 3, 4, 5, 6 carbons this way. The biggest mistake people make is they want to take what's just in this row here, which would make 4 carbons. It's not necessarily how many are in a straight line, it's how many that are connected. So that means we want to gather up this one on the top as well because it's connected to the longest chain. We want to connect these as well. That's how we're going to get the most carbons that are connected in one line. 1, 2, 3, 4, 5, 6, 7 carbons connected all together. This was not connected to it wasn't included in the longest chain. Whatever's not included in the longest chain, if it's not hydrogen, circle it because it's a substituent. So, the fact that it has 2 carbons there make it eth. Remember, if it's coming off the longest chain, it ends in YL, so it becomes ethyl. From here, we need to figure out which direction to number it. I've numbered it here from left to right. We can also number it from right to left. 1, 2, 3, 4, 5, 6, 7. You're looking, when you decide which direction to number it from, you're looking for the direction that gives the carbon with the substituent the lowest number possible. Well, it looks like no matter what, it's going to be a 4. So that means that it doesn't matter which direction we're counting from. It's going to be a 4. And we're going to talk about this more in the next few examples. So, name the chain. We have 7 carbons in a row. 7, the prefix is hept. So that means 7 carbons right there. They're all single bonded. So we're going to end it in ane. Heptane. Now we look at the substituents. It's on the 4th carbon, and it's ethyl. The substituents go before the chain name. So, on the 4th carbon, 1, 2, 3, 4, there's an ethyl group on the main chain of heptane. Okay, we're going to do a lot more of these because it's going to take some practice. First thing you want to do is find the longest chain. So we have 1, 2, 3, 4, 5, 6, 7 if we go that way. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7. So it looks like 7 is going to be our longest chain. Just so happens that that's the chain in the middle. So we have 7 carbons as our longest chain. Circle and name the substituents. Well, here's one. Here's another. The top one has 1 carbon, so it's meth, ending in YL because it's a substituent. The bottom one, once again, is 1 carbon, so it's meth, ending in YL because it's a substituent. Number the carbons. We can go from the left or we can go from the right. So if we go from the left, 1, 2, 3, 4, 5, 6, 7. If you go from the right, 1, 2, 3, 4, 5, 6, and 7. We want to pick the direction that gives our substituents the lowest number possible. So if we're looking at this, the first one is 4 or 4. No matter what, that's going to be the same. But if you look at the one on the right hand side on the top, 6 or 2. We want the lower number. So we are going to cross out the top numbers. We're going to go from the right, starting with 1 being on the right hand side. Because that gives us 2 and 4 as the substituents. Name the chain. So, once again, we have 7 carbons. 7 is hept. So that's 7 carbons. Ending in A and E. So that's because it's single bonded. So it's heptane. On carbons 2 and 4, we have a methyl on each of them. So it's going to be dimethyl. 2, 4, dimethyl heptane. 2 and 4 are the carbon numbers. Di is the fact that there are 2 methyls. A methyl means that there are 1 carbon substituents. So 2,4-dimethylheptane would be your answer for this one. Okay, we're finding their longest chain. 1, 2, 3, 4, 5, 6, 7, 8, 9. Notice I kept going down the chain because they're all connected in the same line. So I have 9 on this chain. 1, 2, 3, 4, 5, 6, 7, 8. There's only 8. So far the longest is 9. 1, 2, 3, 4, 5, 6, 7, 8. Still the longest is 8. 2, 3, 4, 5, 6. The longest is 9. Pardon. Looks like no matter what, 9 carbons is going to be our longest chain. That's going to be our longest chain right there. Next step, circle and name the substituents. Okay, we have a methyl here. If you look at this one, it's ethyl. We have another methyl here. And we have a propyl here. We need to number the carbons now. If we go from the left, 1, 2, 3, 4, it starts at 4. If we go from the bottom, 1, 2, 3, 4. Okay, so either direction, the first substituent is going to be on 4. When you come to a situation like that, where you're going to be looking at is alphabetical. Ethyl comes before methyl in the alphabet. So that means when you have a toss-up, the ethyl will win. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So name the chain. 9 is nonane. Non is for 9. ANE is for single bonded. We need to name the substituents. We have an ethyl, 2 methyls, and a propyl. Do this alphabetically. So the first one will be ethyl. So on the 4th carbon we have an ethyl. Then alphabetically methyl comes next. So we have 4 and 6. So 4, 6 dimethyl. And then on the 5th carbon we have propyl. Now I'm running out of room, but that's okay. 4 ethyl, 4, 6 dimethyl, 5 propyl, nonane. So figure out your longest chain, figure out what the substituents are, and then number them according to what gives you the lowest number for those substituents alphabetically. Alright, we are going to keep going. Find the longest chain. I'll give you a minute to think your way through this. I found the longest chain to be right here. You could have also gone down rather than gone up. You would have gotten the exact same numbers and the exact same answer. Circle and name the substituents. I'll give you a minute to do this. I found 3 ethyls and a methyl. Number the carbons. You have to decide going from the bottom or coming from the top what will give you the lowest number for those substituents. I'll give you a minute to figure that out. If we start from the top, the first substituent is on a 3. If we start from the bottom, 1, 2, 3, 4, 5, the first substituent is on a 5. So we are going to start from the top. 1, 2, 3, 4, 5, 6, 7, 8, and 9. Name the chain. So we have 9 carbons there, which gives us nonane. Alphabetically, ethyl comes first. So on the 3, 4, and 5 carbons, we have ethyl groups. Since we have 3 of them, it's going to be triethyl. And then on the 4th carbon, we have a methyl group. So 3, 4, 5, triethyl, 4 methyl, nonane. Finally, we're going to do a practice with having a halogen on there. The rhythm is still the same. The pattern is still the same. You still want to find the longest chain. Your longest chain should have that bromine and chlorine and fluorine on it. I'll give you a minute to do that. We have 7 carbons. Circle and name the substituents. We have chloro, because it's chlorine. Bromine becomes bromo. And then we have a methyl group down here. Remember, anytime that there is a bend in the chain or at the end of the chain, there's a carbon there that you're not seeing. If there is letters at the end of it, that's the element. There's no carbon here. But there is a carbon here because there's no letters written. So there's no carbon here. There's a bromine on the left-hand side instead of a carbon. Number the carbons. If we start from the left, it comes 1, 2. If we start from the right, it's 1, 2. So from there, since they both end on 2's, we look at the alphabet. Bromo becomes before chloro, so we're going to start from the left to the right. So it begins 1, 2, 3, 4, 5, 6, 7. So name the chain. 7 is hept, so it's heptane. The substituents are on 2, 5, and 6. We're going to do this alphabetically. So 2 bromo, 6 chloro, 5 methyl, heptane. Alright, that gives you practice in an overview of naming compounds with substituents. This really takes a lot of practice. I've broken this section into 2 different videos, so that way you can turn around and practice the straight chains, and then come back and practice the cyclical chains.